Hey everyone, Diane here. Today, we're going to be looking at some different multiplication equations and see if we can see a pattern. I'm going to be using some base 10 blocks. I'm also going to show you how to draw these quickly, just in case you want to share all this awesome knowledge with your people. So for this, we'll be using a unit. We'll also be using a rod. And then lastly, we'll be using a flat. Last time, we talked a little bit about multiplication when we solved 14 times 2 and 18 times 2. We talked a little bit about the multiplication and how it is repeated equal groups. And our example from last time had 2 groups of 14. For today, we are going to be focused on multiplying by 10. So our overarching question is, what do you notice happening when we multiply a set of related equations by 10? We're going to place 3 times 1 equals 3 here to have a reference point. The first equation we are going to look at is 3 times 10 equals what? And what does that mean, and what would the product be? Oh. Yeah, that is 3 groups of 10, or 30. Could you think about using the base 10 blocks to represent this equation? What was that? Oh, very nice. I heard some of y'all talking about a couple different ways. Someone brought up that we could use 30 units to show 30. We could also have 3 of the rods because each rod is made up of 10 units. That's interesting. I notice something is going on with these digits. Let's do another one and see what happens. So now let's use these 3 rods and think about 30 times 10. What do you think that would be? Oh, that's a good idea. I heard one of you suggest making 10 groups of 30, so I'm going to do that now. So, what I see here is that we have 10 groups of 3 rods. So, when we're looking at that, I want us to think about what we are seeing. So, is there anything that changed with these blocks? Exactly. I went from having 3 rods to having 30 rods. Whew, goodness. That's a lot to keep track of. Is there anything that I could do to make it easier? Oh, what was that? Did you say trade 10 rods for a flat? That sounds like a good plan to make our pieces more manageable. I'm going to do that now. 6, 7, 8, 9, 10. I can trade that. 2, 4, 6, 8, 10. Could trade that. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Trade that. Whew, now I've got 3 flats. Do you all notice a pattern with our products? I keep noticing something. I keep seeing that there's 3 of something. What's that all about? So let's look back at our problem so far. When I multiplied 3 times 10, I started off with 3 units of 1. When I multiplied by 10, I ended up with 3 rods of 10. Then, when I started with 3 rods of 10 and I multiplied by 10, I ended up with 3 flats of 100. But why? Can you whisper your thinking to me? Oh, that's some good thinking. It probably has something to do with when we multiply by 10. Each time we end up with 3 of the next place value. Why do you think multiplying by 10 would have that effect? Oh, I heard someone say something about place values being 10 times greater than the one before it. Let's dig into that a little more. We know that it takes 10 of a certain place value to make one set of the next one. So if I have 1 and then do 10 times that, I would be at 10. When I think about 1 times 10, my 1 digit started in the ones place, and then it looks like it moves over 1 place to the tens place. So now let's think about that with 10 times 10. That is something I know. 10 times 10 equals 100. What do you notice happening with the 1 digit that time? Exactly. Each time, our 1 is moving over 1 place value. So now, let's try that with our string of equations, and I'm going to use a digit card just so that way you can see. So we saw that 3 times 10 would be 30 and moved over 1 place. Then we figured out that 30 times 10 would be 300. Because each place value is 10 times larger than the place value to the right, the digit 3 doesn't change, but its value does. I wonder if this would work if it was a different number. Let's try it with 12 times 10. You draw your base 10 blocks out, and I'm going to make my 10 groups down here. Let's meet back up in just a bit. All right, I see here that we've got 10 groups of 12 now. What did you find the total to be? Would you tell me? Exactly, we ended up with 120. Remember how we talked about the digits shifting? Did that still happen here? It sure did. How cool is it that we have a 2-digit number multiplied by 10 and the digits were still shifting? So today, we explored a set of related equations that dealt with what happened when we multiplied numbers by 10. We noticed that each time the digits stayed the same, but the values changed. The pattern worked because each place value is 10 times larger than the place value to the right. Next time, we're going to explore this pattern more and see how far we can stretch our thinking with the pattern. See you then for the next Power of 10 exploration. Bye, y'all.